In our last video, we solved the problem of transistor from 2022 to 2016. Okay. Today we will start from 2007 and we will go up to 2013. As 2014 and 15 there is no transistor question. Okay. So today our goal will be to solve the transistor problem from 2007 to 2013. So this is the first problem. They provided the value of alpha is 0.98, okay, and they told us VBE is equal to 0.7 volt, okay, and IE is 2 milliampere, and they want to know the value of R1 is how much, the value of IC, which one is IC? This value is IC, and the value of this current is IB. So we need to know these three quantity. Okay, so let's start it. Here, this is the emitter terminal, right? Here, the voltage I write down VE. Okay, this is collector terminal, and here we assume the voltage is VC, and this point will be base is the VB. Okay, this current will be emitter current IE, and this current is IB. This current will be IC. Okay, and here we assume the current will be I2. Here in R1 resistance the current will be I1. Okay, and from the source the current I assume is IS. Okay, so we can write down IS equal to IC plus I1. Okay, I've just applied the KCL at collector terminal. Then we can write down IS equal to IC plus I1. Okay, and I1 equal to IB plus I2. And here you can see from the 100 ohm resistor 2 milliampere currents is flown. Okay, so VE will be RE multiplied by IE. From here we get 2 milliampere into 100 ohm. From here we can write down 0.2 volt. Okay, so P equal to 0.2 volt and I equal to 2 milliamps. Now we get the value of V 0.2 volt and we know VBE equal to 0.7 volt. That one equal to VB minus VE. We already know the value of VE is 0.2 volt. That means VB will be 0.9 volt. Okay, so here the voltage will be 0.9 volt, right? This point VB 0.9 volt, that means this point also the voltage is 0.9 volt. So from here we can get the current I2. I2 will be 0.9 volt divided by 20 kilo ohm, okay, equal to 45 microampere. Clear? From here we already got the value IE 2 milliampere, I2 45 microampere, VE is equal to 0.2 volt, VB 0.9 volt, right? Now they provided the value of alpha. Alpha is 0.98, right? And we know beta equal to alpha by 1 minus alpha equal to 49. Okay, so beta will be 49. Okay, here you can see IE is 2 milliampere, right? So we know that IE equal to beta plus 1 into IB. Here beta is 49, so IB will be 40 microampere. Okay, IB is 40 microampere, right? This IB is 40 microampere, I2 is 45 microampere. Then we can write down I1 equal to IB plus I2 equal to 85 microampere. Okay, And as IB is 40 microampere, we can write down IC equal to 1.96 milliampere. Why? As beta into IB. Beta is 49 and IB is 40 microampere. If we multiply these two, then we will get IC equal to 1.96 milliampere. Now you can see we already have the value of IC 1.96, value of I1, right? So from here we can get the value of IS. So what will the value of IS? IS will be IC 1.96 plus what is the value of I1? I1 is 81 microampere, so minus 3. Okay, so this will be, if we just add these two, then we will get 2.045 milliamps. Okay, so we already got the value of IS, right? Now they need IC, IB. So we already get the value of IC and IB. Now we need to know the value of R1. Okay, so here I write down IS is 2.0545 milliampere, IB equal to 40 microampere, okay, IC equal to 1.96 milliampere. So just remove this one. Now we need to know the value of R1, right? How we will get that one? We can get the value of R1 from R1 equal to this point potential is Vc and this point potential is Vb. That means the value I1, the current flow through the R1 resistance will be Vc minus Vb divided by I1. Okay, this is true, right? As this potential is Vc, this potential is Vb. So I1 value will be Vc minus Vb by R1, or we can write down R1 will be Vc minus Vb by I1. We already have the value of I1, 85 microampere, and we already have the value of Vb, which is 0.9 volt. Now we need to know the value of Vc. So how we will know that one? Just apply the KCL at the outer loop, this loop. Then we will get Vc equal to 12 minus 3.3 multiplied by IS, right? IS equal to 2.045 milliampere. So from here we can write down the value of Vc will be 5.252 volt. Okay. Now just put the value of Vc in this particular equation. Then we will get 5.252 minus 0.9 divided by 85 microampere. Then we will get the value of R1 will be 51.2 kilo ohm. Okay, so this is a very basic problem and you can easily solve it, but you need to know the current in all of the branches, right? So you just need to apply KCL at each and individual node and use the Ohm's law, then it's very easy. Okay, so now what is our result? R1 is 51.2 kilo ohm, IC equal to 1.96 milliampere and IB equal to 40 microampere. Okay, now we will go to the simulation and just I will make this circuit and will show you that the result is completely matched with the simulation result. Okay, so this is the circuit diagram, right? In the question, they just told us find out the value of resistance R1 such that the current flow through this ammeter, that means the IE, right? This is the emitter. So the current flow through this ammeter will be 2 milliampere. So we need to find out the value of this resistance is how much such that the IE will be 2 milliampere. Okay, let's simulate this circuit and see the current status. Now you can see the reading of the ammeter is 2.95 milliampere, right? So that means 10 kilo ohm is not the answer. So what we need to do, increase the resistance and just check the value will be higher or lower, okay? So if I increase the resistance, then you can see is close to 2 milliampere, right? So I need to increase more. Is 1.97, right? And our answer is 51.2 kilo ohm, right? So just match our result. Okay, so just here you can see I just match the resistance with our calculation result, right? The value of the ammeter current is perfectly 2 milliampere, right? The VB is 0.9 volt. V is 0.2 volt, right? And here you can see the IC is how much? 1.96 milliampere. Okay. So, and here the I2 is 45 microampere, I1 is 85 microampere, and IS is 2.04 milliampere. So that means in our calculation, all of the current and the voltage is exactly matched with our simulation result. Okay. Now let's go to the next question. This is a very basic problem. This is a voltage divider bias, and I already have some video on voltage divider bias. We all know that this circuit is equivalent to this one, right? Where this one is a VTH, the voltage, this one RTH, they act as the base resistance, this is RC, this is RE, and this one is a VCC, right? And we know that the value of RTH is equal to R1 R2 divided by R1 plus R2, where this is R1 and this is R2. Okay, and the value of VTH is equal to R2 divided by R2 plus R1 multiplied by VCC, where VCC is 20 volt, right? If we do this calculation, then we can directly write down the circuit. Okay, so what is the value of RTH? RTH will be 10 kilo ohm parallel 2.2 kilo ohm. So equal to 10 into 2.2 divided by 10 plus 2.2. It will be 22 divided by 12.2 equal to 1.80 kilo ohm. Okay. And what is the value of VTH? VTH will be 2.2 divided by 12.2 multiplied by 20. It will be equal to 3.6 volt. Okay, if we get the value of VTH RTH, it will be very simple to do the calculation. So just redraw the circuit and put the value of VTH and RTH. This voltage is 3.6 volt, right? This resistance is 1.8. R1 will be 1K and RC is 3.3 kilo ohm. VCC is 20 volt, right? So if we apply the KVL in the input loop, we can write down 3.6 equal to IB into 1.8K plus 0.7 plus beta plus 1 into IB into RE. Here in the problem they didn't provide the beta. Here I assume beta is 100. Okay. So from here we can write down 1.8 IB plus 101 IB equal to 2.9. From here IB will be 2.9 divided by 102.8. This is equal to 28.21 microampere. Okay, so IC will be 2.81 milliampere. Okay, as IC is 2.81 milliampere, then IE will be 2.81 plus 28.21 microampere. So we can write down 2.838 milliampere. Now apply the KVL at output loop. We can write down 20 minus 3.3 into IC is 2.8 milliampere. Okay, minus 1 into IE is 2.838 milliampere equal to VCE. VCE will be 7.889 volt, right? Here they want the value of Q point, right? So Q point is nothing but the value of VC, comma IC. Okay. So what is the value of VC? VC is 7.889. And what is the value of IC? IC is 2.81 milliampere. So this is the Q point. Now let's go to the simulation circuit and just check our calculation is matches with the simulation or not. Okay. So in the question, they provided this circuit diagram, okay, and they told us to calculate the value of Q point, okay. And here I assume the beta is 100, right? We need to check the value of VC and value of IC, right? In our calculation, we got the value of VC is 7.89, right? Now you can see the voltmeter shows the value of VC is 7.89 volt, okay? And the value of IC is 2.81 milliampere, right? So in our calculation also, we got the same result, right? The I is 2.81 milliampere, IC is 2.81 milliampere, and VC is 7.89 volt. That means our calculation is exactly matched with the simulation result. Okay. Now let's go to the next question. This is a very basic question, and they need to know the value of IC, IE, and IB and VC, right? That means we need to calculate all of the current and voltages in this particular circuit. Here they provided ICO is 20 nanoampere. Okay, this one we can neglect, but as they provided, so we just need to take into consideration. Okay, so we just need to take in the calculation. Okay, so we can write down, if we do the KVL in the input loop, we can get 5 minus IB into 200K minus 0.7 is a VB, right, minus beta plus 1 into IB into 2 kilo ohm is the RE is equal to 0, right? From here we can get IB equal to 5 minus 0.7 divided by 200 plus 202, okay? As beta is 101, beta plus 101 multiplied by 2 is a 202, right? Is equal to, we can write down 10.69 microampere, or we can write down 10.7 microampere. Here they provided beta is 100, right? So we can write down IC equal to beta into IB plus beta plus 1 into ICO. In general case, we neglect this term, okay? As ICO you can see is 20 nanoampere is very low. But as they provided the value of ICO, we need to take into consideration, okay? So here IC will be, beta is how much? 100 into 10.7 microampere plus 101 into 20 nanoampere is equal to 1.072 milliampere. Okay, so we already get the value of IC. So the value of IE will be IC plus IB, right, equal to 1.089 milliampere. Okay, now we already have the value of IC, IE, and IB. Okay, so I just write down that one. IE is 1.089, IC is 1.072, IB is 10.7 microamps. Okay, now we need to know the value of VC. So what we need to do? Just apply the KVL at the outer loop. That means in this loop. What we can write down? 10 volt equal to 3 multiplied by IC 1.072 plus VCE plus 2 multiplied by 1.089. Okay, from here we can get VC will be 10 minus 3 into 1.072 minus 2 into 1.089. So this is equal to 4.606 volt. Okay, so the value of IC is 1.072 milliampere and VC is 4.606 volt. Okay, now let's go to the simulation circuit and just check the result is close to this one or not. Okay, as in that simulation circuit we cannot set the ICO 20 nanoampere, right? So that's why we need to consider the circuit without ICO and just check the result will be very close to our calculation result. Okay. Okay, so this is a circuit they provided in the question. Here you can see the VBB is 5 volt, VCC is 10 volt, and we need to know the current IB, IC, and IE, and the voltage VCE. For the VCE, I connect a voltmeter take the reading of the VC. Okay, so let's simulate this circuit. So here you can see the value of the IB is 10.7 microampere, right? The value of the IC is 1.07 milliampere and the value of the IE is 1.08 milliampere. That is perfectly matched with our calculation, okay? And the value of VCE we get is 4.62. In our calculation we get around 4.61. Why? As at that time there is a ICO is 20 nanoampere, right? Here we cannot set that one. That's why this is little bit different. But our result, our calculation result is matched with the simulation data, right? Let's go to the next question. So here you can see they provided PNP transistor as the arrow is in inward side. Okay. Now you can also see the polarity of the voltage source is changed for the PNP. This one is the negative, this one is positive. Here this is negative, this is positive. So as they change the transistor from NPN to PNP, that's why also change the voltage source. So don't worry about that one. We will just use the simple KVL and we will get the result. For the PNP, this will be plus, this will be minus VB. Okay, this will be 0.7 volt. I direction will be this side, as this is the plus, this is minus, so current will be like this. This will be plus, this will be minus, and in this side will be IB. Okay. Now you can see if we apply the KVL, this plus minus, we write down 3 volt. This is minus plus, that means the change of polarity. Then it will be minus IB into 200 minus plus same minus 0.7. Voltage current direction will be this side, that means this is plus, this is minus, that means minus 0.5 into beta plus 1 into IB equal to 0. Okay, from here we can get IB equal to 2.3 divided by 200 plus 50.5. That one is equal to 9.11 microampere. Okay, so we already get the value of IB and the direction of IB is this side and the value of IB is 9.11 microampere. So for the IC also the direction will be this side. Okay, so we can get the value of IC will be beta into IB and that one equal to 911 microampere, or we can write down 0.911 milliampere. Okay, then we can write down IE will be IB plus IC and that one will be equal to 921 microampere. Okay, so now we already have the values of IB, IC and IE. Now we need to know the value of VC such that we can know the region of operation. So apply KVL at the output terminal, then we will get VCE will be minus 10 plus 1 multiplied by what is the value of IC? IC is 0.911 milliampere plus what is the value of IE? 0.5 into 0.921 milliampere. Okay, and that one is equal to minus 8.63 volt, right? Now you can see the value of VC is minus 8.63 volt, right? Now for this is the PNP, right? For the PNP, the saturation also will be the 0.2 volt. Here it will be the minus 0. The polarity will be different, right? So that means this transistor is working in the active region. If you have some doubt with the minus, just think this is the NPN. For the NPN, what will be the value? VC will be 8.63. I will show in the simulation. Don't worry about that one. The value of VC in the PNP, if minus 8.63, then for the NPN will be plus 8.63. For the NPN transistor, we already did some maths where we saw that if the voltage of VC voltage is greater than 0.2 volt, that means the transistor is working in the active region. Right here, just think about this one is a PNP, right? So PNP means that this will be the just this is a minus, right? So that means this transistor is also working in the active region. Okay. Now, first question is done. That means the transistor is working in the active region. Now we need to know that the value of V0. How we will know that one? We need to know this voltage, right? What is the value of V0? V0 will be minus 10 plus 0.911. That will be equal to minus 9.089 volt. Okay. Now let's go to the simulation circuit and I will show you the effect of PNP and NPN. That means I will do the same circuit. I will change the circuit from PNP and the NPN transistor and I will show you the voltage will be the same. The polarity is the different. So here you can see this one is the NPN transistor and this one is the PNP transistor, right? As the arrow is towards the inside and this one is the arrow is towards the outside. This is the NPN and this is the PNP. So we did the problem using the PNP and for the PNP you can see the voltage source is in the negative minus 3 volt and minus 10 volt. Now let's simulate this one. Here we can see the result we get is minus 8.63 volt. Okay, the value of Vc, right? Now I will show you that if I just replace the PNP transistor with the NPN one, then we will get the similar result, right? How we will do that one? Here we just delete the PNP, okay, and replace it with the NPN, right? Now as I connect the NPN, we need to change the polarity of the voltage source, okay. At that time what we got? We got 8.63 as a VC, right? So now we should get the same result. So let's simulate this one. Here you can see we get the value of 8.63, right? So whether you use the NPN transistor or PNP transistor, that the output will be the same, just the polarity will be different. Here you can see this is the positive 10 volt, this is the positive 3 volt. That's how we get the positive 8.63 volt for NPN transistor. Just replace this one with the PNP transistor and change the polarity. Now you can see negative 3 volt, negative 10 volt. So we got negative 8.63 volt with the PNP transistor, right? So what I want to say, if you get any question from PNP transistor in the examination, just do it as the NPN transistor. The answer will be the same. Just polarity will be the different. Okay. So if you think that the voltage source is negative, the transistor is the PNP, maybe the KVL will be different. Don't think too much. Okay. Just think that this is the NPN transistor with a positive voltage source. Do the calculation and just change the polarity. The answer will be the same. Okay. Next question. Write down RC is 10K, RE is 270 and beta 45. They want the value of RB when VC is 5 volt, right? So this one will be IC and this current will be IB. So this current will be IC plus IB. So if we use the KVL at the output loop, we will get 24 equal to 10 into IC plus IB plus 5 plus 0.270 into IC plus IB. Okay, from here we can get 10.270 IC plus IB equal to 19. So IC plus IB equal to 19 by 10.270. This will be 1.850 and we know that IC equal to beta into IB. So we can write down IB into beta plus 1. So IB equal to 1.850 divided by beta is how much? Beta is 45. So this will be 40.21 microampere. Okay. So we already get the value of IB. So IC will be how much? IC will be 40.21 into 45. It will be 1.809 milliamps. Okay, so we already get the value of IC and IB. Okay, now we need to use the KVL at the output loop to get the value of RB. Okay, so now just this one, we will get 24 equal to RC, that means 10 into IC plus IB plus RB into IB plus 0.7 plus 0.270 into IC plus IB. Okay, so from here we will get 10.270 IC plus IB plus RB into IB equal to 23.3. Okay, so if we just put the value of IC and IB, then we will get 10.270. IC is how much? IC is 1.809 milliampere and IB is 0.04021. Okay, plus RB into 0.040 equal to 23.3. Okay, so if we just calculate this one, then we will get the value of RB. So we can write down RB equal to 23.3 minus 18.991 divided by 0.040. So it will be equal to 100 kilo ohm. So the value of RB equal to 100 kilo ohm, such that the value of VC will be 5 volt. So let's solve this problem. Here they provided alpha is 0.99, okay, and they need to know the value of beta. Okay, so we all know beta is equal to alpha by 1 minus alpha. Okay, so if we substitute the value of alpha, then we will get 0.99 divided by 1 minus 0.99. Okay, this will be equal to 99. Okay, so if alpha is 0.99, then beta will be 99. Okay, so this will be the answer. Here you can see I didn't take ICBO, okay, as our formula is beta is equal to alpha by 1 minus alpha. Now go to the next question. Here they provided common base current gain. Okay, they didn't write down alpha, beta or gamma. Okay, they just write down common base current gain. Right now, I think I already do this kind of problem in my last video. Okay, but I will do it again. So the common base mean, if this is a transistor, this will be the base is common. Okay, here will be emitter and here will be collector, right? So the input current will be IE and the output current will be IC, and the current gain of the common base configuration is called alpha, and that one equal to IC divided by IE. Here you can see IC is output current, IE is the input current. That means gain is the output by input. Okay, so the current gain is alpha, and that one is equal to 0.98. Right now, from here we can say beta will be alpha by 1 minus alpha, and that one equal to 49. Okay. Now, here they provided IE is 2 ampere. IE equal to 2 milliampere. Okay. And ICBO is 12.5 microampere. Okay. So we know that IC equal to alpha into IE plus ICBO. Okay. Alpha is 0.98. IE is 2 plus ICBO is 12.5 microampere. From here I can write down IC will be 1.97 0.25 milliampere. Okay, and they need to know the value of IB. So IB will be IC by beta, and I already calculated beta is 49, right? So IB will be 40.2 microampere. Okay, so if alpha is 0.98 and IE is to 2 milliampere and ICBO is 12.5 microampere, then we will get IB will be 40 microampere and IC will be 1.9725 milliampere. So this is the last question of today's class. Okay, in this problem, they need to know the value of RC such that this transistor will work in the saturation region. Right? That means this voltage VCE should be equal to 0.2 volt. Okay, and we need to know the value of RC at that particular time. Okay, so we will consider this transistor is working in the saturation region. That means this VB sat will be 0.8. We can write down IB is equal to 5 minus 0.8 divided by 200k. Why? As VBB equal to here 5 volt. That means equal to IB into 200k plus VBE sat. From here, IB will be 4.8 divided by 200k. That means it will be 24 microampere. IC will be beta into IB. That means beta into 24 microampere is equal to 2.4 milliampere. Okay. Now, if we apply the KVL at output loop, we can write down 10 minus IC into RC equal to VCE. Okay. IB is 24, right? And IC is 2.4 milliampere. Right. So VC is how much? 0.2 and ICRC will be 10 minus 0.2. So RC will be 9.8 divided by 2.4 milliamps. It will be equal to 4.08 kilo ohm. Okay, that means this RC, this value 4.08 kilo ohm will be the minimum RC value such that the transistor will operate in the saturation region. Why? As if we increase the value of RC from 4.08 to suppose we increase to 5 kilo ohm, then what will happen? The voltage drop at the resistance RC will be higher. Why? As the current IC is 2.4 milliampere. Right? Now, if RC is 5 kilo ohm, then the voltage drop will be more than 10. Here the source is 10. Then transistor will go to the saturation region. Okay, and if we decrease the RC from 4 kilo ohm to 3 kilo ohm, then what will happen? 2.4 milliampere is the IC. That means the voltage drop across RC is how much? It will be 7.2 volt. Right? That means the VC will be 2.8 volt. That is higher than the VC saturation. Okay, so that means the resistance, if I draw like this is the point of 4.08 kilo ohm. Okay, if I increase the resistance, then this will be saturation region and this will be active region. This is minus, this is plus. So let's go to the simulation circuit and I will explain you this one. So this is the circuit they provided in the question and we need to find out the value of RC such that this transistor will operate in the saturation region. That means we need to find out the minimum value of the RC. Okay, above that one, that transistor will operate in the saturation region. Below that one, the transistor will operate in the active region. How we will know that one? We will check the value of VCE by changing the value of RC. If we saw that in some value of RC, the VCE is 200 millivolt or 0.2 volt, so that is the minimum value of the RC such that the transistor is operating in the saturation region. After that, we will increase the resistance RC and we will check the transistor is operating in the saturation or not. Okay, and then we will decrease the resistance and we will check the transistor is move on the active or not. Okay, let's simulate the circuit. Now you can see the value of RC is 3 kilo ohm and voltage VC is 3.7 volt. That means the Vc is greater than 0.2 volt. Okay, that means this transistor is working in the active region. Now what we need to do? We need to increase the value to, suppose I increase to 5 volt. Now you can see it's already 193 millivolt. That means the resistance should be little bit lower. So I lower down the resistance and I lower down to 4.92 kilo ohm. Okay, and you can see that if we make the RC 4.92 kilo ohm, then the output voltage VCE is 0.2 volt. That means this is the minimum resistance such that the transistor will operate in the saturation region. If we increase the resistance to 7 volt, you can see the VCE will be dropped. It's 145, right? That means the transistor is already moved to the saturation. And if we move to, suppose if we move to 4 kilo ohm, you can see 4.11 kilo ohm, you can see that the VC is 1.37 volt. That means the transistor already moved to the active region. Okay, I did some little bit calculation mistake in my problem. That's why you can see the value is 4.08. Okay, that is a little bit mistake is there. Why? While I calculate the IB, at that time I just calculated 24 microampere. The 4.2 divided by 200 should be 21 microampere. Okay, I did the mistake and I make it 24 microampere. Okay, just a calculation mistake. That's why the output we get is 4.08 kilo ohm. But actually you can see the IB is 21 microampere, IC is 2.1 milliampere. Then we will get the value of RC will be 4.92 kilo ohm. As you can see in the simulation circuit also we get 4.92 kilo ohm. Okay, so please ignore that mistake and do it by yourself again, and you can see that the result will be the same as the simulation circuit. Okay, my goal is to clear your concept. I think I did that one. Okay, so that's all for today's class. Thanks for joining. Thank you. Bye bye.